usage of DiskArray engine. So I'm going to talk about pyramids and how to plot large raster data interactively. So what is a pyramid? So the idea is we have very large data that we can't fit into memory or on the screen, but then we can build a pyramid out of it. So we aggregate every 2 by 2 pixels together, and then the next level and the next level, going from high resolution to coarse resolution data and thereby decreasing the amount of data that we have. Then we want to compute these pyramids for our data. So there's basically currently 2 ways. You can either do it in memory, starting from any abstract dimensional data array, and then basically calling pyramid here and setting a resampling method. And then this takes some time. So for this raster data, which is 40,000 by 20,000 pixels, it takes around a minute. And then for larger data, we can also just do it on the disk. So we start from a data set that is already available as a ZAR file, and then we save the pyramid also into the ZAR, and saving the different levels as different subgroups. And this computation is currently using DiskArray engine. And then we can also access pyramided data. So there's also pyramid data in GeoTIFF, for example, or I think maybe also other TIFF types. There's pyramids in ZAR. So we can just load the data from a path or even from a cloud, from an S3 bucket. That's kind of working, but the latency currently is still too high that it's actually usable. And then after we've done all of these preparation steps, we can actually use this to plot our data interactively. So here we saw our data is 405,000 by 175,000 pixels. That would just crash the machine immediately. And so we see the different layers are getting smaller and smaller until we get somewhere that we can actually put on the screen. And to just do that, we can then just plot. This is above ground biomass data for the whole globe on a 100-meter resolution. And then we get the global picture, but we can also just interactively zoom into here. Or we can have a look at the Amazon, where we can then see some deforestation patterns. And that works quite interactively, quite nicely, because the plot is at all time only accessing the roughly 1,000 by 500 or so pixels that you actually need to put the data into your figure. And it's going to select the resolution based on the area of interest that you're currently looking at. But then we don't only want to do nice interactive visualizations, we also want to do computations on the data. So the next step is we get multiple of these pyramided data sets and do computations on them. So here we just do a broadcasted diff. So currently broadcast is implemented and map for a single pyramid is implemented, so that we don't only we do the computation not on the full resolution and then wait for a few hours to maybe a few days, depending on your data. But here we can just do this, get a lazy broadcast from DiskArrays, and then immediately get this result. And then we can also just plot the result, which should be, oh shit, And then you get immediately the whole globe on the coarsest resolution. So this is just a few thousand pixels per. But then you can just zoom in and say, okay, that looks interesting. Let's have a look at, okay, what is happening here, or do some other analysis that normally you have your area of interest that you're mostly looking at, that you like, oh, these are some areas that are sometimes working, sometimes not, so I want to first look there, and then I see whether it's okay-ish working, and then I can start the analysis for the whole full resolution data. And that's basically the main aim of Pyramid Scheme. And so just as an outlook, so we also want to do pyramids in multiple dimensions, so not only space, but maybe also time, and also either just have the pyramid on every time step, or even do pyramids in the time dimension. So do aggregations on time. I'd like to also see more use cases, maybe for other fields that have also large data that are interesting to look at. So understanding more formats, integrate this all with the DiskArray engine computation, so that we not only do broadcast, but can do more interesting map slices, moving window operations, and thereby opening it up for more use cases. Thanks.
So currently you're mostly showing us 2D kind of pyramids, but could you do 3D right now? You said space, so.
Yeah, it's not, I mean, currently it's just, the pyramid is only computed in 2D.
Okay.
So I think that's basically the next step I'd be working on, to also get 3D, or actually, or the time dimension is more interesting for us, is like, but then also sometimes it's not clear, for me at least, not clear what the interface would look like. Because in 2D, everyone is basically nowadays used to zooming into a map.
Sure.
It's clear how to define your area of interest. But for time, there's also some interesting questions there.
I work with time data. What I wanted to ask, I don't know if you covered it and I just missed it, but when you're doing the pyramids, it's some sort of like aggregation, but can you choose the aggregation function, or is it always mean?
No, you can, here in your computation, you can here set a resampling method. That can be, basically it gets a 2x2, I mean, we could even think about doing other resampling or other aggregations, but currently it's just doing the 2x2 moving window, and basically it expects the 2x2 matrix, and then you can do whatever you want with it. So you can any Julia function, or even, I mean, yeah.
Thanks.
Okay, any further questions?
Hi, thanks very much. Do I understand this right, that this basically this raster which defines of how the hierarchy actually works, that this always has to be some kind of matrix? So could you, so basically like zooming in means that you're looking into like based on some kind of like a rectangle, so that you're basically zooming in through like a rectangle? Because I've only learned recently that Uber actually uses hexagons in order to have this hierarchical format. And so I'm wondering whether is that a smart idea, or is that actually just like fancy stuff that no one actually ever would use in practice? So basically just wondering whether do you have to stick to this like raster being like a rectangle, or can you zoom in with other shapes?
You could zoom into other shapes. I mean, the hexagons, this is more of a DGGS. I can't remember something dynamic discrete global grid systems. So the idea is to get rid of the problem that you have not equal area. For example, if you have that long rectangular pixels. A colleague of mine is currently working on on a DGGS Julia package. And we are also discussing how we can link these together to get pyramids on, or use pyramid scheme to compute the pyramids for the hexagons in a smart way, and then also be able to plot them.